Hi everyone. Students, in today's lecture I will discuss about end of star's life. The main sequence isn't forever. The story of star's death begins at the point at which the star leaves the safety and security of the main sequence. The main sequence is the long main track observed in the HR diagram. Here in this picture, the long track represents the main sequence stars. Students, we have learned that stars seen in the upper left of this track are hot, blue and massive, weighing 10 to 100 times the mass of our sun or possibly more. Stars at the lower right end of the track are cool. By stellar standards, they are red and may only contain a tenth of the mass of our sun. We have also learned that blue stars tend to be called high mass, while stars like our sun or smaller are often called low mass stars. When a star leaves the main sequence of the HR diagram, the star is seen to move towards the right of this plot. This movement is the result of the star becoming redder, as represented by this image. When a star core runs out of hydrogen fuel, the core can no longer sustain the outward radiative force that balances the force of gravity, which pulls everything inwards. Therefore, the star will no longer be in hydrostatic equilibrium. This loss of radiation pressure results in the star core collapsing, as it is represented here. When a star burning primarily hydrogen suffers from such a collapse, it will contract until the core reaches about 100 million degrees. At that temperature, the star can begin to burn helium in its core. Helium will become the main source of energy for the star at this point in its life, as it fuses to create carbon and other trace elements. This image actually represents the helium star. However, if we look just outside the helium core, we can see that the core is surrounded by a shell of hydrogen that is also burning. The hydrogen burning shell is slowly consuming more material as it moves outwards through the star. As the helium burns hotter than its predecessor, the hydrogen core, it burns more rapidly. Therefore, this phase of star's life is shorter, as shown in this image. Once the helium core is exhausted, the core will once again collapse. As it collapses, the temperature will once again increases. If the collapse leads to a temperature of 600 million degrees, the star is able to burn carbon. Such a core would be surrounded by both helium and hydrogen shell. Once the carbon burning is complete, the cycle can again repeat, leading to neon, oxygen, or even silicon burning, with the core becoming heavier and heavier. As each layer is hotter than the last, the star burns through its core more rapidly. For example, a star could take billions of years to burn through its hydrogen, whilst it may only take hundreds of years to feed on a carbon core. By the time we reach silicon, it's possible for a star to consume its core in about a day. The multiple layers of a star seen here have led to these stars sometimes gaining the nickname of onion stars, as onions have layers, as this image represents an onion star. When learning about fusion and fission, we discovered that the most tightly bound atom is iron, and that no more energy can be gained by either breaking iron apart or by smashing iron nuclei together. As a result, there is no fuel left for a star to burn through. Fusion in its core must stop and the star will die. This image represents the collapsing of a star. Students, this is all about this lecture where we have discussed about the death of a star. Thank you so much.